name is Savannah Avery, and today I'm going to be presenting my Lab 1 of Physics 2212, which was an experiment about the charge on tape. So the purpose of this experiment was to learn about the charges and their interactions using everyday objects, such as clear plastic tape. This lab provides a model of point charge interactions and the forces involved, as well as providing a computation of the electric field of a point charge at specific locations. The result was that the system of two tapes was found to be in equilibrium, and that the forces of gravity from the earth onto the tape and electricity from one tape on another were found to be both tangible and equal and opposite to each other. For this experiment, two pieces of clear tape were ripped apart to create charged tapes, one being positive and one negative. This was then repeated in the exact same fashion to create two positively charged tapes and two negatively charged tapes. Throughout the rest of the experiment, we decided to use the positively charged tapes. One tape was then hovered in the air by using the electric force of the other tape to repel the top tape and oppose the gravitational force of the Earth on the top tape. Measurements were then made, such as the distance between the original position of the top tape and its final position, as well as the mass of the tape was noted. Because the top tape was in equilibrium, as it was not moving, then electric force could be computed by first calculating gravitational force. Then electric field and charge could be computed algebraically. There are some very important physics principles that should be noted. First, Newton's third law. For every action, there is an equal and opposite reaction. Thus, when a system is in equilibrium, the net forces should sum to zero. It's also important to note that charge can be computed by first measuring the electric force on an object and then using the principle electric force is equal to electric field multiplied by the charge of the object that the electric field is acting on. It's also important to note that electric field can be computed by multiplying the constant k, which is 1 over 4 pi epsilon naught, by the charge of the object creating the electric field divided by the magnitude of the relative position vector squared multiplied by the associated unit vector for that relative position vector. Subsequently, I created a computational model of this experiment using Python. I first created a point charge model of the two pieces of tape, tape A being the top tape and tape B being the bottom tape, shown as the two blue spheres. I then computed the force of gravity on tape A using the gravitational constant on Earth and the mass of the piece of tape, which I then found to be 1.962 times e to the negative third newtons per kilogram in the negative y direction. I had already algebraically solved the charge on one piece of tape, and then subsequently solved for the relative position vector, the magnitude of that vector, and the associated unit vector using the values observed in the experiment and known physics equations. I then used those values to compute electric field, which I found to be 8.40427 times e to the fourth in the positive y direction. I then used the principle electric force is equal to electric field multiplied by the charge of the top tape to compute the electric force on the top tape due to the bottom tape. I found that to be 1.962 times e to the negative third in the positive y direction. I then modeled these forces acting on the top charges as the green arrows. The arrow in the positive y direction is the electric force, and the arrow in the negative y direction is the gravitational force. It's important to note that I multiplied the force vectors with the visualization constant so I could see the arrows. Finally, I compared the electrical force to the gravitational force to check if the charge I algebraically solved for made sense, which it did. Some final important observations are that if electrons had positive charges and protons had negative charges, then the tapes would have opposite charges than were documented in this experiment. It's also important to handle the charged tapes as little as possible because their charge will be absorbed by and thus transferred to the neutral objects in contact. Thank you so much for watching my presentation. I hope that you enjoyed.